Hello, hello. So I hope you're all ready. Next speaker is going to talk about POS security, so please give a warm welcome to Emin.
Hello, thank you very much for having me here, and thank you all very, very much for staying in Japan during a typhoon. So it's just wind, it's not that big a deal, and this country has withstood Godzilla. It can handle wind, and we can all handle the wind. So today I want to talk to you about proof of stake, proof of work, and some fun ideas that we should all consider as a community. So I've been thinking about this topic, of course, for a long, long time, and it started out by us looking into this much vaulted, this thing that has become almost religious, this notion of decentralization that's at the core of many decisions made today in cryptocurrencies. So we started to look at this scientifically, just how much decentralization is there out there, and what exactly are we paying to get to that level. And my thesis here is going to be very, very simple. Proof of work and the decentralization that it brings is incredibly limited. We have to move to proof of stake. And on that front, I have a suggestion for this particular audience and an offer. And I want to talk about it very openly and put certain topics, some of them might be difficult for some people, on the table. So one of the things we did was, starting in 2015, we did a very long, longitudinal study of proof of work networks. We looked at Bitcoin and Ethereum, and we discovered a few things. So this graph shows the bandwidth available to a node, to a Bitcoin node versus an Ethereum node. Okay? So, and then of course, there's one line that's for Tor. So it's better to be to the right. And you can see that Tor nodes have very low bandwidth, as you would expect, because they get the anonymity. You can see where Bitcoin is. And you can also see that Ethereum nodes are actually doing fairly well as well. So there's a lot of bandwidth available there. There's a big, big network. When we look at the network location, we discovered some interesting factoids about both Bitcoin and Ethereum. Bitcoin turns out to have the majority of its nodes housed in data centers. 58% of Bitcoin nodes at the time of our study were in data centers. Ethereum nodes tended to be geographically more distributed. There are many, many more of them. At the time we did this study, there were about slightly less than 10,000 Bitcoin nodes and slightly more than 25,000 Ethereum nodes. This community is strong, it's large, it's huge, and it's globally distributed. And that's fantastic. That does mean that the node-to-node communication latencies are a little higher, as you can see on this graph. The green bars are more further to the right, which is not good for this graph. But regardless, it's not so bad. Their communication latencies are about 100 milliseconds, not that bad. And there are many, many, many of us, and that's fantastic. Now the problem is, when it comes to making decisions, those nodes that we run bring no value. Okay? The entirety of the blockchain is created and controlled by a very small number of mining pool operators. At the time we did our study, the Bitcoin blockchain was being created by 19 mining pools. The Ethereum blockchain was being created, 99% of it was being created at the time by 11 mining pools. That's gotten a little better today, I just checked, and there are about 37 of them. That's kind of nice. If you look at the few that actually control the hash power, it's tiny. So Bitcoin, you could launch a 51% attack on Bitcoin, you could revert the chain, you could rewrite it after making 3 to 4 phone calls. And the same is also true for Ethereum. So all of that anxiety, all of those internet attacks, all of those decisions and compromises made in the name of decentralization come down to a tiny amount of decentralization, a tiny amount of distribution. 3 to 4 people define this thing, and that's it. So that's a crazy, crazy thing to be doing. Not to mention the environmental disaster that is proof of work. So Nakamoto consensus consumes an immense amount of energy. Just so we can visualize this, it's about the equivalent of the entire energy consumption of Austria. It's the equivalent of 2 Denmarks, 3 Irelands, and if you want to think about those cooling stacks and so forth that you see when you see a nuclear power station, the 4 nuclear power plants go into cryptocurrency mining. And so there are, of course, two different approaches to this. Some people are inherently concerned about this because it melts the polar ice caps. It literally kills the polar bears. I'm in that camp. It really, like, when I think about what I'm doing and what that's helping the world, where that's taking the world, I feel terrible about myself. Other people are more like, well, I got mine, screw everybody else kind of mode. And, and there are many other sort of justifications they use. That's okay. And to them, especially the store of value crowd. And to them, I say, well, look, you're leaking a lot of value out of your system. So to be able to construct your blockchain with the help of these, whatever you want to call it, 11 to 19 miners, or 37 miners, whatever they are, you are paying an immense cost. There was a very recent study that was issued just maybe last week that looked at the the externalized costs of mining. And they found that for every $1 of Bitcoin value created, there was an external cost of 49 cents of health and climate damage in the US and 37 cents in China. So this is not something we can stand behind. Anybody with a conscience should be able to say, look, this is really, really bad. We should not stand for this. And when it comes to the security, well, what's going on? The security of the coin is being secured by an investment in mining rigs that is equivalent to about 2 to 3% of the market cap of the coin. Okay? So keep in mind that a mining rig is some kind of a stake. It's a stake in that hash function. Somebody decided I would rather mobilize my capital and turn it into this format, which is this mining rig. And the amount of money that went into that is only 2 to 3% of the sum total. That's tiny. That is not much at all. And those rigs are not specific to a coin. For example, if you own a Bitcoin mining rig today, you could take that rig, use it to attack whatever other coin that shares BSV, crash BSV, rewrite their chain as much as you like, and then after you've completely screwed over BSV, you could go back to your Bitcoin mining unaffected. You simply gave up the opportunity cost of mining on BTC, but you did not lose your stake. Your hardware was usable afterwards. Now compare that to proof of stake, where an attack, a successful attack, will burn the cash that you put into the system. And compare that again to proof of stake systems, where we see upwards of 60 to 70% of the coins staked in the system. The security, the amount of money you'd have to burn to attack is much, much higher than proof of work systems. I hope these points somehow sort of make the point that, the narrative that you get from the Bitcoin loudmouths is essentially just a whole bunch of security theater, a whole bunch of decentralization theater. So, what can we do? Well, so to sort of think about what one could do, one has to understand where we are today. And one has to understand one's options. When we talk about, well, okay, let's ditch proof of work. That sounds like a sensible thing to do. We are all people with consciences. But how are we going to do that? Well, until recently, we had just one choice because of the particular history. This is what we had. This area of distributed systems has been around for about 45 years. And for the first 35 of those years, we were always in this framework that we call the classical framework. The two people who came up with that framework, Leslie Lamport and Barbara Lisko, independently received Turing Awards. They're brilliant. And within that framework, hundreds, maybe thousands of different consensus protocols have been proposed. We knew about all these protocols 10 years ago in 2009. Satoshi knew about those protocols. He looked at them and he said, these protocols are no good. They're very, very fragile. They don't lend themselves to an open permissionless system. And that's why he came up with his Nakamoto consensus protocol, which showed the world what one can do with BFT systems. We showed the world what a coin could do, what a permissionless coin could look like. So it was a fascinating proof of concept. But we are now beginning to see its shortcomings. It is not as decentralized as it could be. There's natural monopolistic effects where one miner becomes dominant over time. And the amount of energy going into it is enormous, and so on and so forth. Now, what can we do? We can go back to the 70s, the 80s, the 90s, and dust up old papers and put new lipstick on old ideas to try to make them look prettier and okay again and try to fold them into our current context. No matter what we do around that topic, we will find that those protocols are incredibly fragile. We knew this at the time, we knew this 10 years ago, we know it now. If you talk to various different people, if you talk to Vlad Zamfir, for example, about his expectations of ETH 2.0, he will tell you that he fully expects consensus failures. And that's because of the fact that these protocols are very, very fragile. Something interesting happened last year. There was a new protocol family launched. It's called Avalanche, and it works differently from the others. It is not based on voting. It is not based on a single round or just a few rounds, but it's based on repeated rounds of sampling an audience. And that gives us an incredibly different set of properties, and I want to talk about that. And what I really want to talk to you about today is something we built using that protocol. It's called Athereum, and it's a testnet for Ethereum. Okay? So you can use it today, and I'll show you, maybe I'll try and show you a video. We came up with this cool logo. It's AVA plus Ethereum, and you combine the two, and you've got Athereum. And at the core of it lies a very simple idea. Okay? So the idea is to take the Avalanche consensus protocol and to adapt it for use with Ethereum. And just like you have multiple testnets for Ethereum, there's the Ronston, this, that, we can also have the Athereum testnet that people could use. Now, the properties of this testnet are interesting. It is very, very, very fast. These protocols are incredibly fast. We're getting 3,000 decisions per second on the Athereum testnet, on the linear chain that we build. It's totally ordered. We're getting higher numbers. Some of you might have heard me talk about Avalanche. We have much higher numbers for Avalanche, but that's a different kind of a system that has partial order and asset management and so forth. That's a different thing. This is a little slower because we're creating a totally ordered chain, and yet it's 3,000 decisions per second. Now, by the time you put it through the EVM, that goes down drastically. And the numbers that we're seeing today are about 200 transactions per second. But that's due to the current EVM design that we're using, which we stole entirely from Geth. So it's not only high throughput. I think a lot of this game turns out to be centered around TPS numbers. TPS numbers are incredibly easy to fake. And if you want to sort of look for an example of this, ask the Hedera Hashgraph people for a demo. The thing that's really important is finality. And I suspect that most people have not seen just how awesome these systems can be when they operate with quick finality. So the Avalanche family gives us finality, or can give us finality, in less than a second range. That's our target. On our current testnet, we're getting 90 milliseconds, super fast. And the most important feature of this protocol is that it can incorporate any number of participants. So if you want to add 1,000 more people to directly participate in the protocol, it can absorb those 1,000. This is something that nobody else can say. Libra, for example, is a classical protocol. It's using the fastest known classical protocol, designed by my student, by the way, who now works on AVA. And they're targeting 100 validators. That's the best they can do. More than 100, then the n squared starts to bite them. So these protocols work differently, and they can accommodate, as I said, thousands to millions of participants. You and I and all of those existing nodes that I counted before, that we looked at before, they can be part of the network. They can help the network make decisions. They can help secure the network. Law enforcement can send 100 subpoenas in the same day, no problem. They cannot send 25,000 subpoenas to all 25,000 of us. And finally, the implementation that we have is byte-by-byte compatible with the EVM. So everything that we know, we can just take and run on top of this new infrastructure. So the plan here, or the idea here, is to spoon Ethereum over to the AVA network. And so some of you might not have heard the word spoon before. A spoon is a fork that's friendly. And I'll talk about why this is friendly and why this is good in a second. And that creates Athereum for us. In doing so, we plan to, of course, preserve all balances. Okay? And in doing so, we plan to preserve all community tooling. So things like Solidity, MetaMask, Remix, all layer 2 solutions, they should continue to work untouched. I'll talk about the slight exceptions and the things we discovered along this path in a second. But the core idea is to preserve everything that we know to do, except move it to, but give you a platform where you can do it much, much, much faster. Not move, just give you an additional alternative. So, some things that there's a lot of noise out there, so it's been about a year and there's been some discussion around this. I want to make sure that everybody understands the basics. We're talking about a totally ordered chain. You know, as I mentioned before, Avalanche builds a partially ordered DAG, but within the DAG, we create an actual straight up, you know, regular chain that looks exactly like the current blockchain today. It's asynchronous. There are no baked-in assumptions related to timing or delivery of message latencies. Okay? So it's robust. It tolerates imprecise membership in network views. So I could think that the network consists of this many people. You could think that it consists of that many people. That's not exactly the same. That would be catastrophic if we were using a classical protocol. For Avalanche, it's no big deal. That's totally normal. It'll work beautifully, even in the presence of differing views. It's secure. Unlike most other protocols, you could actually tweak or parameterize Avalanche, or the Avalanche protocol, the core protocol underneath, to withstand attacks that are greater than 51% of the stake. Now, the protocol won't necessarily make progress. We cannot guarantee liveness in the presence of such a big attacker, but it can guarantee safety in the presence of such a big attacker. This is unprecedented. It is a gracefully degrading protocol. So classical protocols typically, I think you've heard Vitalik talk about 3f+1, or you might have heard other people talk about the 1/3 cutoff. They typically what happens with them is they can handle attackers as big as 1/3 of the network, 33%. And if the attacker is slightly bigger than that, then he's guaranteed to win. Okay? So that's an interesting property. With this new family of protocols, the degradation is graceful. If we gear up the network for an attacker size of 33%, and the attacker mobilizes 40% of the stake in the network to attack the network, I think this is incredibly likely, but suppose it happened. He doesn't get to win immediately. And again, this is unprecedented. What happens is, sure, because he's bigger than we anticipated, it's because he's bigger than what we geared the network for, we can no longer make the usual security guarantees. The probability of a safety failure is not going to be once every 20,000 years. But it also doesn't mean that he wins immediately. Instead, what it means is he might be able to create a safety violation, not in 20,000 years, in a time that's a little quicker, maybe in 5,000 years or 2,000 years. And that's a very nice situation to be in, because when your assumptions are violated, your system doesn't just keel over. So I was going to do a demo, but I think what I'm going to do, well, I can show you pieces of this demo. Let's see. So I don't know what there is to look at. All these demos look the same, and they look kind of bad. So you can see, are we hearing it? We're not hearing call and talk. So in essence, what you get to see here is on the left, we have a block explorer. And on the right, we have a screen where, a terminal where he's going to issue 2,000 transactions. And that's my Ether wallet that everybody knows and loves. It took me 5 minutes to set it up with a dropdown. So once you have the dropdown, you can say, look, I'm going to issue some transactions. Don't send them to the regular main Ethereum network. Send them to the Athereum testnet. So I don't know what's going on with this demo. Stuff is happening. Okay, no, maybe it is moving. All right, because we can't hear the volume or the sound, we can't really tell what's going to happen. And I can't fast forward through this because I don't have a keyboard up here. So what should happen is you should see an enormous flurry of activity as soon as he issues his transactions. You know what I'm going to do? Instead of staring at an empty screen where nothing happens for a while and then things just kind of float by. I'm going to let you imagine that this thing goes really, really fast, okay? So please bear with me. It really does go very, very fast. And I'll give it maybe 2 more seconds. Oh, yeah, okay. So, yeah, what we were planning to do for this audience was set up a lottery, okay? So we have this lottery contract, and you can see that, you know, just for testing purposes, we ended up putting 11,000 registrations there. We're going to ignore those. And so as of this moment, it's going to be checkpointed. And you can just connect to this network and send any message to this contract, okay? And you just register your public key. We'll do a drawing, and we'll distribute some swag to everybody. And that's Colin talking in the background. And you know what I'm going to do? I'm going to...
this is a pretty straightforward script, actually.
All right, he's going to issue his 2,000 transactions.
And watch it happen.
All right, Colin, press the
First phase is
key.
actually creating 2,000 accounts.
Okay, and then you can see just how fast this thing is. And it's kind of amazing to watch it grow super freaking fast. I'm going to skip this. Okay, so we decided to do this 2 weeks ago, and much of my time was spent not on technical stuff, but on talking to people and saying, look, this is all very friendly. We want to make sure that nobody's upset about what we're about to do. It's a test net, and so forth. It's very early for us. There are no denial of service protections, okay? We do have the gas logic in there, but we're not using it. So if any one of you decides to DOS us, you can. And so please don't, okay? It doesn't really demonstrate much, the fact that you can DOS a test net, okay, big whoop. But you know, it's a fun thing to play with. And so my proposal to the community is that we put up this testnet, make this testnet available for you, and we play around with it. That's really the entirety of the proposal on the table as of now. But we are also thinking about creating a spoon. So what's the spoon again? We're going to identify a height in the future at which we're going to duplicate the state of the chain at that height. Okay? So that means all of the balances are preserved. So everybody who holds ETH, they now hold that much ETH on AVA. Okay? ETH on Athereum. And all of the contracts that are deployed on ETH today are going to be deployed also on ETH on Athereum. So this gives us a very, very fast network, and a scalable one right now. That's a wonderful situation to be in. There are lots of other groups working on making Ethereum fast. You know about Ethereum 2. You heard about Vlad's CBC Casper work. I'm sure there are others out there. So it's wonderful to be in a community with so many people trying to make the infrastructure better. This new infrastructure we're offering is completely optional. We're not asking anybody to burn their mainnet coins. You don't have to buy into this thing. You just get it all, okay? And there's no lock-in, and you don't have to change any piece of software. We don't have to go and talk to anybody. There is no permissioning step involved. It's just out there. You just add a different interface, a different RPC endpoint, and you're off to the races. It does not compete with ETH 2.0. It, in fact, takes the pressure off of ETH 2.0, because there is now at least a test network initially, and perhaps sometime soon a real network, that actually works, and works at scale. And as there are EVM improvements, we can incorporate them. Now, we're not EVM people. We're not going to be making those improvements ourselves. That's still the domain of the Ethereum Foundation. We are simply giving a new layer 1, the very, very lowest layer, and we're relying on the Ethereum Foundation for the development of the EVM itself. That's, I think, the core intellectual sort of thrust of this endeavor here. And it demonstrates, as I said, that it's possible for ETH to scale today. And it preserves everything that's, at least to me, quintessentially Ethereum. So all balances, all contracts, all tooling, and of course, all of the colorful shorts and so forth, they all remain Ethereum. It's just that one layer gets a little faster. So spoons are nice. And one of the things that they help us do is identify future problems currently brewing on chain. One of the main things we discovered immediately is that the tooling itself is not currently geared for blocks that are lightning fast. So we're getting block times that are about 90 milliseconds. The tooling assumes that you're getting at most 1 block per second. So that's a bit of an issue that we have to keep in mind, because that might no longer be true. We're also identifying a bunch of smart contracts that assume a certain block interval, somewhere between 12 to 15 seconds between blocks. That's no longer going to be true. Even no matter what happens with the switch to POS, those contracts will have to be rewritten, and if they cannot be rewritten, they will be broken. So keep that in mind, because this is coming, and this is a good way, a testnet is a good way to explore these problems before they happen. Much more importantly, and the thing that I'm most excited about, is that Athereum would help bring more people into the infrastructure. We are all cut out, unless you own some mining rigs, and I'm sure some of you do. We're cut out from the infrastructure. We're not participating. All of that diversity at the network layer is not reflected during consensus. We have no voice. Only the miners get to produce the blockchain. And now we can all participate. That's an interesting situation to be in. There's no cabal formation because there's no committee selection. It's not like this protocol is going to be sub-selecting a small group. It's not like EOS where we vote on each other and us 21 people are in and then we vote on the next person to come in, etc. There's none of that happening. Everyone gets to come in and participate because of the efficient way that this protocol can work. So some people might object to this. I worry a lot about this because, you know, I've been there for the DAO fork, I've been there for the Bitcoin Cash fork, I've been there for the BSV fork, and so forth. One thing to keep in mind, so one of the things that they might object to is, hey, this ETH on Athereum is not the same as ETH. And that's true. But this is not a zero-sum game. We can create excess value for everyone. The fact that we're now introducing something else or the fact that we're showing to the world that ETH can actually scale, should indeed make everybody, all the boats go up. And it's much better than a burn or a lock or an explicit transfer. Let's see, there are existing miners that made an investment in mining rigs. They will, I think, very vociferously be against any push like this. I don't know what to say to them, but there was very clear guidance from everybody that mining was going to end for Ethereum at some point. So they took a big risk. So I expect them to be vocally against this idea, but then again, they took that risk on their own despite the guidance to the contrary. And there might be people out there with ego tied up in particular solution strategies. Again, I don't know what to do about that, except to say that the Ethereum community distinguishes itself. The reason why I'm here, why I love this community so much, is because of its devotion to scientific study. That if any group of people are going to look at the merits of different solutions and pick accordingly, it's this community. So let's do it that way. Let's do it in a principled manner. Just based on what happened yesterday, there's this whole issue about airdrops and tax obligations and so forth. This kind of a spoon is explicitly mentioned in that guidance as a non-tax reportable event. So it's not like you suddenly have a tax obligation. There are some other boneheaded things that are in that guidance, but at least those things don't affect this particular idea. So then there's the final thing that I want to talk about, which is why are we doing this, right? So there will be people who sort of are suspicious of my motivations here. I don't know what to do about that. I think all of you know me. I've been around for long enough. But let me try to enunciate sort of what kind of a person I am and what kind of thing we're trying to do here. I am here, and I've done everything I ever did to make the space better, to a fault, and I'm proud of my record on this. Many applications demand high scale right now. We do need a solution, and we do need to show to the world that this area can overtake Wall Street and move it to a better foundation. It can overtake governments and move them to a better foundation. And most importantly, it can overtake corporations and business logic and make them trustworthy again. Well, so where is that? Well, it's not in Bitcoin, I assure you of that, at 3 to 5 transactions per second. And at the moment, with 20 TPS or so, it's not in Ethereum 1.0. This is one path forward. Of course, I want to demonstrate and test my implementation, our implementation of Avalanche underneath. And so that is one of the key motivators for us. I want the creativity of this community coming in and checking the protocol implementation that we have. This is a great way to shake out any issues we might have. And I want to see it with the whole set of things that have ever been deployed on Ethereum. That's a very rich set of applications. I want to see those and see whether or not we can support them. And of course, I want to create awareness for the underlying AVA technology. So you guys should all come and check it out. This stuff is super fast. Maybe you use it just for this, and then you go away. Maybe you don't touch it. That's okay too. But maybe some of you will stay and check out the other AVA features that we have. We have a bunch. I'm not going to go into them here, but it's a cool platform. So if you're interested, this is the the link. This is the link, athereum.ava.network. There's a very long write-up on how to configure my Ether wallet to point to it. We've also configured MetaMask. It's just you don't have to change any binaries. You don't have to trust any of us. It's trustless technology from the ground up. You just add one RPC endpoint, and you're off to the races using this testnet. So with that, thank you very, very much. Thank you all for coming to the talk.